is for lecture 1, lecture 2, lecture 3, 4. Function, introduction for function. Same like SPM, but a bit detail for domain and range. Composite, same like SPM. Inverse pun, this one maybe involve the new function. Okay, new function adalah for exponential and logarithmic. Okay, so concept same like your punya SPM. Okay, function. Okay, the first lecture, okay, function. Okay, objective. Define a function. Nama for function. No function. No function lah kan? Okay, this is very important lah kan? Identify the function using the vertical line. So ingat, vertical. Okay. Then identify one-to-one using horizontal and baring. And objective. Okay. Objective for this lecture. Okay, you want to sketch graph. Find domain. Sketch graph. Domain. Range. Okay. Kita baca dulu. Okay. Functions defined as relation in which every element in the domain has a unique image in the range. Domain, range. Domain, range. Or codomain. Okay. In other words, function is one-to-one function, one-to-one relation, or many-to-one relation. You ada banyak relation kan? One-to-one, one-to-many, many-to-one, many-to-many relation. But when the relation called function, when this relation is one-to-one and many-to-one. Okay? Jadi, onto function. So a function which is element of the range is mapped to at least one element of the domain. Means that semua, all, okay, we use all the elements. So we call onto function. And this is onto function. This is not it's not used. So we cannot say this onto function. Okay. And kan, one-to-one function. Lihat. Function which every element of the range corresponds to exactly one element of the domain. One. This is one-to-one function. Okay. And this one 1 to B, 2 C, 3 C. This one share same range. You can say this one-to-one function. Okay. And how to identify functions and one-to-one function. Okay, so to identify function, we use vertical line. This one is good for objective ni. So question objective. Define which one is function using the vertical line test. Vertical line test. Define which one is one-to-one function. Define using horizontal line test. Horizontal line test. Online test pula kan. So algebraic approach pun okay. Okay. Either you use graphical or algebraic. Okay. For algebraic nanti. Step for algebraic later. So vertical line test to show this is function. Okay. So draw a vertical line parallel to y-axis. Okay, vertical line macam ni, graf ni is vertical line. Okay, parallel to y-axis. Sini kan. Ni straight. Check if the vertical line cuts the graph at only one point, then the graph is a function. Okay, cari sini. Mana dia punya? Okay, vertical kan, straight. Ni vertical, semua vertical. Cuts at only one point. This is function. Vertical line. Okay. Okay, yeah, and this one is not a function because I cut at 2 points. This is not a function. Okay, make sure ingat to determine the function using the vertical line test to determine the function. Okay, please remember this is good for your objective. Horizontal line test. Okay. Okay, draw a horizontal line parallel to the x-axis. Okay, and then check if the horizontal line cuts the graph at only 1 point, then the graph is one-to-one function. So kita check, this is okay. Kau tengok horizontal line test. Horizontal line test. Check or cuts at only 1 point. This is one. This is mana horizontal line one-to-one function. Okay, yang ini horizontal line test cuts at only at 2 points. So this is not one-to-one function. Okay, you have to remember to determine the function using line test. Function. Determine the one-to-one function using horizontal line test. This is good for your test. Okay, and then next step, algebraic approach. Okay, identify the one-to-one function using the sketch the graph or without using graph using algebraic approach. Okay, let's say Budia nak show this is one-to-one using algebraic approach. First step, okay, substitute, choose the two domain x1, x2 member of domain F. Okay, in the function if x1 equals x2, then it is one-to-one function. Jadi kita kena follow ni dulu. Okay, function f is said to be a one-to-one function if each different element in x corresponds to the different image in y. So kita let's say dia bagi fx is equal to something. Kita choose two number inside the domain and then substitute dalam ni. Then last show this the two taken ini number is equal. If equal, you can say conclude that there is one-to-one function. Okay, let's say example 1. Example 1 using algebraic. This one to show to check the function is one-to-one. You can use graphical, but now we are going to use algebraic. Graphical macam ni lah. This is quadratic, right? It's my graph. It's my graph quadratic. Okay, this is x-axis. Okay, shift down. This is x squared minus 3. Confirm this is not one-to-one function using graphical. Why? Why? Because of horizontal line test cuts at 2 points. 2 points, not 1 point. 2 points. So this is not one-to-one function using graphical. Now we're going to use algebraic. Yes, algebraic. Okay, so let x member of real number domain. Nanti kita tunjuk how to find domain. Okay. So let x1, x2 domain member of domain F or real numbers. Okay. So now it implies that if fx1 equals fx2. Okay, contoh macam ni lah. Macam ni mapping. Okay, this domain domain, this is a range. x1 sini, x2 sini. Okay, for color Okay, and then x1 match dekat fx1, right? This is fx, right? Okay, x2 confirm map dekat fx2. Okay, so now kita define, kita declare this one sama, fx1 equal fx2. Kita dah khabar this is sama. So now we need to show this one also sama. Means that this one one-to-one function. The same thing, the same object je. X1, X2 same object. Okay, so that's why kita define ni dulu. Define ni. So fx1 same fx2. fx1 masuk dah ni. Okay, x1 squared minus 3. Okay, this one x2 squared minus 3. Okay, benda yang sama kan, this is the same function function. fx1 masukkan jadi fx1. x2 masukkan di fx2. Kita define benda yang sama. So we need to show is it x1 is equal to x2. If yes, samalah. Kan? Sama tak? Okay. So now kita explain, exchange semua, simplify. Dapat ini. Kuadratik atau you dapat ini plus minus x2. Kalau tak sure, you boleh this kuadratik bawa ke sebelah, then factorize. Kuadratik kan factorize. Then is equal to 0, x1 equals x2 or x1 equals negative x2, right? Ada two numbers. So now you ada x1 equals negative x2 or x1 equals positive x2. Okay, so this one maknanya this one you have two numbers. This is considered not one-to-one function. Okay, since x1, x2 domain of f and x1 equals plus minus x2, therefore f is not one-to-one function. Macam sebab dia ada dua. Okay, ada sini satu, ada sini satu. Dia bukan macam ni saja. Okay, because maybe x2, x1 negatif dia or positifnya. It is not one-to-one function. Saya baca. Okay. Then example 1. Okay. So ini. Okay, the graph kalau ini linear, actually linear. Kalau linear, graph dia simple je, right? This is y equals mx plus c. 3 cuts y. This is 3. Nah, this is dia punya yx. The graph linear. Okay, kalau tengok daripada graphical, linear graph, nak show, nak determine this is one-to-one, you guna horizontal line test. Jadi horizontal line test ni cut mana tu? So dia cut at only one point. This is one-to-one function. Okay, so kita nak show using algebraic. Ini graphical. Okay, nak guna algebraic juga. So the same thing lah. Kita nak show, ambil the domain ni x1, x2, masuk dalam jadi fx1, fx2. Kita define ini sama. Okay, let x1, x2 in the domain of ni. Tak payah cari, dia bagi tak apa. Okay, so kita if ada if ada naik fx1 equals fx2, kita dah define ini sama. So we need to show adakah x1 equals x2. If yes, that one is one-to-one function. Okay, if no, bukan. Okay, so substitute x1 plus 3, x2 plus 3. then x1 equals x2. Tak ada lain dah, ni je. So we can define, okay, since x1 equals x2, x1, x2 in the domain of ni, therefore it implies that f x1, kalau nak lebih lagi lah, x2, therefore f is one-to-one function. Okay, simple je lah untuk ni. Okay, you all okay tak? You all senyap je. Okay, okay dah. Okay, so macam ni cukup enough lah. Okay, okay, so dah given dah, dia bagi kan, dia bagi domain. Nanti dia belajar macam cari domain. So the graph is, macam mana graph dia? Okay, graph dia, this is 3 into 3. So the graph macam ni kot, kan, macam ni So macam ni graph dia. Okay, depends the domain ni, macam tu lah graphnya. Okay, so still lagi, you ambil the horizontal line test, shows like macam one-to-one. This is one-to-one. Okay, and using the, kalau using dia sini macam ni juga lah, malah nak tunjuk lah. Okay, using the algebraically, let x1, x2 member of ni, sama juga masa saya buat tadi. Okay, x1, x2, ini fx1, fx2, kita define ni sama. Okay, then kita need to show adakah x1 equals x2, kan? So substitute lah dalam function ni. A1 over x1 minus 3 equals 1 over x2 minus 3. Okay, simplify dan dapat. So now kita dah kata ini sama, implies that sama. Okay, so f is one-to-one function. From the graph pun dapat one-to-one function. Betul kan? Okay, D, this is the graph V shape. Graph dia macam ni because sometimes kita tahu dia punya pattern graph dia. The graph macam ni. Okay, so using the horizontal line test, the cuts at 2 points. So this is not one-to-one. Okay, how to show using graphic algebraic. This is graphic algebraic. Okay, sama. So saya tunai. So let dulu x1, x2 in the domain. Okay, this fx, right? fx1, fx2. Kita habak dia sama h x1, x2 sama. So substitute this one, this formula yang ini kan, absolute value punya definition is like this, right? Okay, yang ini tengah sini boleh buat square root of x1 square root of x2 square, and then nak get rid of square root by squaring both side, dan dapat benda ni. Then yang ini macam x squared equals 4, x plus minus 2 lah, mana plus minus, plus minus. So okay, this is because of, okay, because of hx1 equals hx2, therefore x1 equals plus minus x2. So h is not one-to-one function. Okay, so the not one-to-one function. This is a basic graph. You kena tahu, jangan blur sangat. Okay, biar let's say kalau lecturer say that, okay, constant, graph constant, imagine, linear, quadratic, macam mana? Jangan blur je, kosong kan. You belajar apa since form 1 ke form 3? Graph semua kan, simple graph. paling teruk pun paling apa? Form 4, right? Okay. Jadi kalau kata linear, straight line. Linear straight line. Okay, this is the straight line. Okay, linear. Habis tak apa. Okay. Quadratic. Berapa lama belajar quadratic? Smiling graph, set graph. Dan simple, U shape. Okay. N. UN. Smiling, smile, suka, tak suka. Kan? Reciprocal. Okay. Macam ni lah. Saling-salingan ni. Okay. Square root. Square root lebih mudah. Bentuknya macam square root lah. Ni. Senang sangat. Square root bentuk macam square root. Kan? Square root. Kan? Jadi senang. Dia jangan tak ada langsung. Jangan blur sangat pasal graf At least ada sikit basic dia punya imaginasi. Kalau kata okay, graf linear, still linear x kan, tapi plus 3 means shift up 3 kan, macam ni lah, angkat sikit. Maksudnya like y equals mx plus c kan, tahu c kat y axis kan, axis quadratic kalau plus 3 shift up 3. Contoh ni lah, kalau reciprocal ini confirm dia punya denominator not equal to 0. Kita tahu lah tu. So x not equal to negative 3. Nanti kita tengok domain dia. Square root. Square root nanti macam mana tengok nanti start y, start kat sini. And this is square root punya. Okay. Jadi graf sama. Yang ini tak payah hafal. Kena faham logik lah, logik. You all macam physical ada logik. Boleh tengok kan. Jadi tak payah banyak hafal sangat. And then kalau let's say you kena tahu nak belajar domain range ni, domain refer kepada x axis. Domain. Okay, domain. And then range refer to y axis. Okay, ini input, output. Okay, domain range. Okay, domain penting kan. Pada sini wujudlah bayang dia, range. Okay, so example 1 lagi. Okay, jadi this given purple ni, x ni domain. Okay, yang hijau ni y. So dia maps, -1 maps to 1, -2 maps to 4, semua 1 maps to 1 semua kan. So sekarang domain purple mesti guna all, list down all domain. Codomain semua yang ada kat situ. Okay, range only the codomain yang diguna, range. So domain must use all. Ni baru kita panggil function. Okay, kalau domain tak digunakan or even satu, we cannot say this is function. Okay, example, contoh, bolehlah bagi sekarang. Okay, x minus 1. Okay, akan ada x not equal to 1. Why? Well, because when x equals 1, 1 minus 1, 0. 1 over 0 is equal to undefined. Jadi kalau domain nanti, this is domain domain. Semua real number except 1. Maknanya kalau list down untuk this one, semua nombor ada. Dia katakan 0, negative 1 apa benda, ni 0 sini 1, katakan 2, 3, semua ada partner dia. Partner dia. Kecuali 1. Tak ada. Why? When 1 ini masukkan jadi undefined. Okay, so now bila satu tidak digunakan kat domain, kita cannot say this is function. Okay, jadi kita kena buang satu ni supaya semua dalam domain digunakan, so that we can call this is a function. That's why the domain is quite important lah untuk function. Okay. So domain range can be determined by using graph or algebraic. Kalau let's say if you can sketch graph, please sketch graph to find domain and range. So tak boleh sangat baru guna algebraic. Okay. Then domain range using graph. Okay, constant. Jadi sekarang you refer kepada y equals mx plus c. Ini tak ada, tinggal y equals c je. Fx c. Because this is constant. Maknanya x tak ada. Graph, macam mana rupa graph? Graph dia straight line, flat. Betul. Y je ada. Dia potong y kan? Y je. This is constant. Graph constant. Okay. Ada straight line juga. Okay. Dan constant. Then dia punya domain. Domain x axis kan. Tengok sini dia ada dia ada image. Range. Kat sini potong ada. Ini pun okay, ada. Semua ada. So from negative infinity up to infinity, x tu ada partner je. Partner dia. Ambil kat sini x, partner ada. Partner. So we can say domain of f is real numbers ataupun from negative infinity to infinity. Sini ke sini. But for range, dia kat at only y axis at 2 je. Satu number je. So range dia only 2 saja. Ini je. Okay. Jadi ini constant. Domain real numbers, range 1 je. Tengok y. Ni tengok x, ni tengok y. Okay. You all kalau tak faham terus kita interrupt ni. Linear function. Linear. X plus c kan. Ada value x. Jadi linear mesti you imagine this is linear. Straight. Jadi from the linear, kalau you nampak katakan x kat sini ada. X kat sini ada. X kat sini ada image lah. Ada range. X kat sini ada. So from negative infinity to infinity ada di partner dia. Okay, that for x ni value. So domain x ni, domain f ni, you tahu real numbers lah ataupun negative infinity to infinity. Okay, to find the range, tengok y axis. Y axis, cuba ambil y kat sini. Ada partner dia. Kat sini ada. Sini ada. Kat sini pun ada. So means that they from bottom to up. Okay, negative infinity to infinity. So we can say range of f also real numbers from negative infinity to infinity. For straight line for linear, domain range real numbers. Okay, kena ingat tu domain range for linear real numbers. Okay. For quadratic spatial-scape, even though linear, quadratic, cubic itu under polynomial, dia punya range tu lain sikit. Domain real numbers. Okay. For quadratic, you dah biasa quadratic, right? Kalau sebut quadratic, please think about smiling graph, set graph. Jangan duk bingung lagi, macam mana rupa quadratic? Kalau saya tanya, sudah ni tak tahu, stupid. Okay. Quadratic, smiling graph, set graph. Okay. Then, given this one, quadratic, jadi kena completeness square. You kena tahu completeness square juga, don't depends on the calculator kan. Kena juga sometimes, this quite important nak tahu completeness square. Okay. Then, atau sketch lah. You tahu this one is quadratic. Smiling graph maximum. Okay, the minimum lah, minimum smiling graph. Then buat completeness square semua atau factorize ke apa benda ke. So when A positive, the graph is macam ni, smiling graph. If A negative, graph is set graph. Jadi kat sini kalau belajarkan dulu kan ada completeness square. This is the extreme value, either minimum or maximum. So because of this smiling graph, this consider minimum. Okay, minimum value. Okay, ni. So the graph is U-shape. Dia kata apa? Find the domain and range. Domain Okay, domain of, tulis elok lah. Kita orang tak suka tulis F. Domain of F. Okay, so tengok X value. Sini ada partner. Okay, sini pun ada partner. Ada, semua ada. Okay, X value semua ada. So from negative infinity up to infinity. Domain is real numbers. Now from negative infinity up to infinity. Domain real number for quadratic. Okay, for quadratic. Range. Tengok Y kan. Y tengok sampai sana ada partner dia. Okay, tak kisahlah dua-dua pun. Okay, this is for range. Okay, range, not to show one-to-one or function, right? Okay, tengok ada. Okay, ada sampai kat sini. Ada and dah tak ada dah graph. Sampai kat sini je. Okay, means this is the minimum up to infinity. Ada something minimum starting dia up to infinity for range of F. Okay, so starting sini tak tahu. We need to complete the square. Dapat negative 49/4. Okay, so when substitute for negative 49/4 ni dapat CRU akan dapat 0. Mana include lah. Included. Starting from negative 49/4 up to infinity. This is range. Okay, settle. Big function. Cubic. Okay, graf dia bentuk macam S. Okay, ni dia graf bentuk S. Macam ni, comel sikit graf dia. Bentuk S. Macam ni lah. Kuda juga tapi panjang sikit. Punya panjang sikit. Macam tu. Okay, so for determine the domain of F, tengok X value lah. Semua kita guna. You tengok. So okay, ada partner dia semua real numbers atau from negative infinity to infinity. For range, tengok dengan mata kasar. For range, okay, range of F, tengok Y kan. Ni ada semua ada. From bottom to up, maknanya real numbers ataupun okay, from negative infinity to infinity. Macam tu. Jadi that one is for cubic. Actually ada polynomial juga. Domain always real numbers. Okay. Laju ke saya? You all okay tak?
Okay.
Okay. So square root macam mana? Imagine graph square root. Cuma imagine graph square root. Bentuk macam square root. Kan? Bentuk macam square root. Jadi tak langsung imagine kan, ada sikit lah. Okay, jadi bentuk macam ni. For square root, okay, graph macam ni. Domain X kan, X. Tengok sini tak ada, no graph. Sampai kat sini 0, ni 0 starting. Ada graph, ada sampai infinity. So starting 0 to infinity. Starting 0. Okay, that one is domain. Okay, for range, tengok Y. Okay, Y bawah tak ada, no graph, no. Sampai kat sini yang bawah ada graph. Sampai jadi habislah ni, tak ada graph pun tak ada kan. Jadi graph macam ni lah. Itu lah kan. For square root dia naik slow sikit lah. Dia slow, dia jimat kan. Maknanya sampai habis. So still 0 to infinity. Jangan tu tak ada graph pun dia naik slow sikit. Macam tu lah. Okay. Absolute value V shape. Okay, V shape. Imagine V shape je. Okay, so for this one cuba fikir domain. Domain, okay, domain X exists. Dari mana ke mana? Cuba fikir. Domain of F. Okay, jadi dia from mana? Ada semua kan? Ada, sekali image ada lah. Sambunglah semua kan? Ada. So from negative infinity to infinity. Atau real numbers. Cuba find dia punya range pula. Cuba fikir. Range pula. Range. Tengok Y kan? Y. No graph. Tak ada graph. Tak ada no graph. Sampai kat sini baru ada graph. Ada sampai atas. So starting 0 to infinity. That one is for absolute value function. Okay. Jadi ni pula. Macam mana rupa ni? Graf dia bertahan juga. Don't worry, jangan rasa seksa je, tak apa. Yang ni dia taklah seksa, saya bagi kat you all di masa-masa sekarang ni just nak expose je. This is the graph Jangan rasa alamak ada ke macam ni kan. Tak ada, dia akan bagi yang elok-elok sikit lah. Dia tak seksa sangat macam ni kan. So sekarang ini graph ni dia bagi dah macam ni. Domain of F. Semua ada partner X ni. Ada. Tapi tak ada. Sini putus. Satu ni tak ada. Buang satu. Semua yang lain semua ada. Ni tak ada. From negative infinity to infinity, semua ada except yang bulat ni. Okay. Maknanya kita tengok ni. This one not equal to 0 kan? Kalau sama 0, tak boleh lah. The function is undefined. X not equal to negative 1 over 2. Oh, ini adalah sini negative 1 over 2. Jadi sekarang semua real number except negative 1 over 2. Atau, you boleh buat from negative infinity to negative 1 over 2. Stop. Negative 1 over 2 to infinity. Domain. Settle. So range. Imagine range pula. Range tengok Y axis kan. Range of F. Tengok Y semua ada. Potong semua ada. Tiba-tiba kat sini tak ada. Ni tak ada sini. Okay, dia ada. So for negative infinity to infinity ada except this one. Jadi tak tahu nilai. How to determine the nilai yang ni? Okay, sekarang tu you all. Apa kita buat dulu? R except something. Macam mana nak tunjuk sekarang? Tunjuk sekarang lah. Dia ini jadikan dia Y equals 3x plus 2 over 2x plus 1 plus. Take write x as a subject. Mana atas 2x plus 1. Okay. Y. Sekejap. Kau kan. Okay, senang sikit. Kalau saya terus buat macam ni. Bawa atas. Sama hal juga cepat. Jadikan dia sebagai subjek lah. Senang buat lah. Tak apa. Lambat-lambat sikit. Okay. Equals 3x plus 2. Bawa ke sebelah. 2xy minus 3x. 2 minus y. Factorize x. Akan dapat nanti 2 minus y over 2y minus 3. So sekarang ambil yang ini. Not equal to 0. y not equal to 3/2. Okay, so sekarang ni yang ini nilai dia 3/2. Okay, atau you boleh tulis dalam bentuk ini, negative infinity to 3/2 stop union 3/2 infinity. It's okay, lepas nanti kita akan concentrate lagi kena baca macam ni Okay, so this is that one untuk rational function. Graf dah habaq dah kan, so ambil je lah. Saya yang tunjuk macam cari kan, negative 2/3 and 3/2, right? Okay, dia dah habaq dah apa. So kita semua ambil je ni dengan ni. Senang cerita. Okay, so sekarang kita teruskan juga yang ini. Okay, yang bawah ni not equal to 0. Okay, not equal to 0. Under square root, okay, under square root always more greater or more 0. Okay, and then when this graph overlap, okay, dia dah 1 over square root kan, maknanya this one overlap lah. Okay, dia ni intersect yang ini, so jawapan is more than. More than kita akan tengok lagi, don't worry, ni tengok je.